The concept of quadratics is often mixed in with the concept of square roots for reasons that we'll see in a later section. So we're going to kind of introduce some basic square root terminology and operations you can do with them. The first of which, we're going to talk about estimating square roots. So if I give you the square root of a number, I want you to be able to say about what it's equal to. And in order to do that, I have a vocab word called a perfect square. And a number is a perfect square if when you take its square roots, you get a whole number answer. So in pink here, I have written down the first 15 perfect squares. This is a list of numbers you should definitely become familiar with if you're not already. All it is, 1 times 1 is 1, the square root of 1 is 1. 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6. And you keep doing that. I went all the way up to 15 times 15 here. So if you take the square roots of 121, for example, that's just going to be 11, because 11 times 11 is 121. So if you know those perfect squares, you can actually get a pretty good estimation of what a square root is going to equal as decimal, even without using a calculator. So over here I have the square root of 125. The square root of 125, I know the square root of 121 is 11. So this one is just a little more than 11. I'm going to say it's about 11.1, because it's just a tiny bit above that. Next up I have the square root of 43. And the square root of 43, 6 times 6 is 36, 7 times 7 is 49. It's going to be somewhere in between these two numbers. It's roughly halfway in between. So I'm going to call that about a 6.5, if I were to estimate that. And you can double check me on the calculator with these, but these are my estimates and they're going to be pretty close. Because I know my perfect squares, I can make a pretty good guess of what I'm going to get. The trouble comes in when you have much bigger square roots like this guy right here. I don't know my perfect squares any higher than 15, so I couldn't estimate that like I did with the first two. So, one thing we can do, there's something called simplifying a square root, and that's what I'm going to teach you guys in the next video. But it turns out that this is the same thing as 15 times the square root of 8. If you don't believe me, you can type both of these things in the calculator, square root of 1800, 15 times square root of 8, you'll get the same answer. I'll go into the next video how I got that. But one reason why this is nice is because the number under the square root is nice and small. Square root of 8 is going to be roughly, it's going to be pretty close to 3, like a 2.9 or something like that. And 15 times 3, estimating this, is about 45. So I'm going to say this guy right here, this whole square root, is going to be like 44.8 or something like that. You can kind of eyeball it based on having that smaller number under the square roots. In the next video, we're going to learn how we get smaller numbers under the square root, which makes calculations easier, and it also makes it easier to estimate an answer.